Hello everybody, we're going to go on to lesson 2 in our factoring unit, chapter 8. And so in the first lesson we just talked about how do you find the greatest common factor. Now we're going to actually do something called factoring, where it's kind of like the distributive property backwards. So you'll be able to factor polynomials by using the greatest common factor. And we don't have any language objectives. Before we talk about factoring with greatest common factor, it's important to look at or remind ourselves what the distributive property is. So the distributive property is we're going to take the 5 and multiply it into the x and then multiply it into the 3. So we end up with 5x plus 15. What we're going to do in this video is 5x plus 15 will actually be the question, and our answer will be 5 multiplied to the parentheses x plus 3. And if we do the same thing, we do 7m multiplied to 2m squared. That gives us 14 and 3m's, 14m3, minus 7 times 6 is 42m. Again, in this video, they'll give us this expression, and we have to make it into this. So we're taking a minus problem, and now we're going to make it into a multiplication problem. So another warm-up we're going to do is, one more time, let's find the greatest common factor between 8x and 30x squared. What I did was the prime factorization of 8, which is 2 multiplied to 2 multiplied to 2, and I have 1x. For 30, I did the prime factorization of that, and that's 2 times 3 is 6, 6 times 5 is 30, and I have 2 x's. So I'm going to find what do I have in common? I have 1, 2 in common, and I have 1x in common. That means they could both be divided by 2, and you could take 1x from each because they at least have 1x. Alright, so we have 9 practice problems we're going to go over. So here's how you factor. You look at both terms, both monomials, and you say to yourself, what can divide 3 and 6? And that would be 3. So you identify what the greatest common factor is, and then I want you to put it underneath each one, and we're going to divide both by that. All right, and what we'll do is put a parenthesis here. We'll take the 3 that we're taking out and put it on the side. All we have to do now is say 6x divided by 3. That's 2x. And then we say 3 divided by 3. That's 1. So notice, we took an addition problem and now we made it into a multiplication problem. And you can always check, because if you do the distributive property, 3 times 2x is 6x, 3 times 1 is 3. You get back to the question. Okay, let's look at this one. We have 24 and 8. What's the biggest number that can divide 24 and 8? And that would be 8. So 8 can divide both of these. Dan? 8 can divide both of these. Also, I want to look at the variables. What you do is take the variable with the lowest exponent. So this is exponent 1. So if they each have an x, you put the lowest one underneath. So this is just x to the first. Now what I'm going to do is I'm going to make myself a parentheses. I'm going to write 8x here. And now I'm going to divide. 24 divided by 8 is 3. 2x's take away 1x is just 1x. Next, I'm going to do 8 divided by 8. That's 1. And notice right here, my x's, those will cancel. Those will cancel out. So this is what I'm left with. I'll put my parentheses a little closer there. I'm left with 8x multiplied to 3x minus 1. All right, let's look at this one. We have 6x minus 12. So what number can divide 6 and 12? 6 can divide both of them. So what I'm going to do is divide them both by 6. So 6x divided by 6 is 1x. And then 12 divided by 6 is 2. I'll keep the minus sign. And then make sure you always write the number on the outside of the parentheses so that you could distribute it in later if you need to. All right. Okay, let's look at this one. We have 2x squared plus 8x. Well, I know that I can divide these both by 2, so I'm going to write a 2 here. And I also know that there's an x in each of them, at least one. So I can take, the most I could take is only 1x because that's all this has to give. So I'm going to take that out. Now remember, what you're basically doing is dividing. So we're going to divide both sides by 2x. If I do that, what's left inside here is this cancels to 1, and here I have 2x take away 1x is 1x plus 8 divided by 2 is 4, and the x's here cancel. Once again, if I multiply 2x to x, I get 2x squared. If I multiply 2x to 4, I get 8x. You can always check your answers. What's the biggest number that divides 4 and 10? The biggest number that divides 4 and 10 is 2. And if I divide them both by 2, if I divide this by 2, 4x divided by 2 is 2x. And 10 divided by 2 is 5. Again, if I multiply the 2 back in, it will turn into this. But don't do that. This is your answer. What's the greatest common factor between 10 and 35? Now I know that 5 can divide both of them. So I'm going to divide them both by 5. I also have to look at the variables. There's an x here and there's 2 x's here. So the most I can take out is just 1x. So now I do that, and what's going to be left? So I'll do 10 divided by 5. That's 2. 2 x's take away 1x. Leaves me with 1x. And 35 divided by 5 is 7. And then these x's cancel. There's my answer. Let's try another one. Here I have 10x squared y minus 15x squared y. So focus on the numbers. What can divide 10 and 15? And that answer is 5. Now look at the variables. I have 1x here and 2x's here, so I can take 1x out. And here I have 1y and 2y. Well, the most I can take is just 1y. Now let's see what's left. Okay, look at what I did to find out what's left in the parentheses. 10 divided by 5 is 2. X squared take away 1x leaves me 1x left over. And this y, those will cancel. They will cancel. Now, the minus sign will come down. 15 divided by 5 is 3. These two x's will cancel out. And 2 y's take away 1y, 1y left over. All right, what's the greatest common factor between 12, 9, and 15? So the biggest number that divides all of them is going to be 3. Next, I have 2 x's here, 1x here. Well, but there's no x's here, so you can't take the x's out. So all you can do is divide by 3. Divide them all by 3. So 12 divided by 3 will give me 4, and then the x squared will stay with it. Then I have 9 divided by 3 gives me minus 3, and the x stays with it. 15 divided by 3 gives me 5, and it's positive, so I'll say plus 5. There's my answer. Last one. What's the biggest number that divides 3, 12, and 30? And that's going to be 3. The biggest number I can divide these by is 3. I see an n in each one, so I'm going to take one n out. And now let's see what's left over. So if I divide this out, these will cancel, and I'll have 2 n's left. Then I do 12, negative 12 divided by 3 is going to be negative 4. And I'll have 1 n left over, because 2 take away 1 is 1. Okay, finally I have negative 30 divided by 3. So negative 30 divided by 3 is negative 10. And if you notice, these ends will cancel out, so they're gone. Here's my final answer. Once again, when you're factoring, you're taking an addition problem, a sum, and making it into a product. So here's our answer. All right, here are the practice problems. Please show work in each one. Don't forget to factor out the greatest common factor and then write the parentheses of what's left. You can check your answer by doing distributive property, and bring any questions you have to class next time we meet. Take care.